Hola, hola, hola.
Hola, mister.
¿Cómo están, muchachos?
Good
Espero que esté
morning.
todo bien. Good morning. Vamos a ver, pin my video. Vamos a ver. Good morning, good morning. All right, then. Today, I hope you're doing well, guys. Thanks for asking. We're going to continue solving quadratic inequalities. Okay, yesterday, we are starting, obviously, solving what one singular example applying the inequalities. Well, today we're going to continue solving the another ones, okay? And remember, if you have doubts or questions, don't hesitate to let me know. Okay, so in the example and instructions, we're supposed to solve the following inequalities, okay? Let's go to write the example number 2. Solve quadratic inequalities and give the answer by means of interval notation, solution set, and number line. Okay, let's go to solving the equation. Okay, for example, we have this inequality. For example, letter B or letter A. Once again, in this case, will be x squared x squared minus 4x greater than equal, in this case, greater than equal than -4. Okay, so remember what we have to do in this situation. The first step, the step number 1, we had to follow. In this case, we had to transform the inequality into equation. Remember, step number 1, transform the inequality into equation. So in this situation, we got x squared minus 4x equals -4. So this -4 passes to adding x squared minus 4x plus 4 equals 0, right? And we have to try to looking for what will be the factorization of terms when simple merely words. Just for trying to practice, we can perform the completing the square technique. X minus half 4 will be 2 elevated at the second power minus 2 second power plus 4 equals 0. Okay, I'm just using the completed square technique just for trying to practice the technique. But if you really want to use the try and error fact technique, don't worry, at the end will be the same. So x minus 2 second power minus 4 plus 4 equals 0. So x minus 2 second power equals 0. We can take square root in both sides. We can conclude x equals 2. Okay, this is going to be the step number 1. Okay, now let's going to apply that step number 2. In the step number 2, remember, we have to create that table of signs. Okay, in this situation, we have to write the polynomial, the interval, the interval in this case, remember, because we have one singular solution, we have to do possible intervals. The first one, -infinite, comma 2, and because this inequality has the equal sign, we can close the brackets in the number 2. And also, Another interval could be positive 2 until positive infinite. Okay. In which values is going to write in interval. In the polynomial, remember the solution was x minus 2 second power. So, you know, x minus 2 second power. And obviously, the answer will be x squared minus 4x plus 4, right? Greater than or equal than 0. But if you want to write the expression, you can do it also. But in this case, won't be necessary because we have one singular term. In that case, that solution that we're going to provide this equation will be enough to remarkable what will be the solution of the inequality. So we have the polynomial and we have the intervals. Okay, so in the first one, we have to choose one number located between negative infinite and 2. Would you like to choose one singular number, please? Between negative infinite until the number 2? Choose one singular number.
-3.
Negative 3. Okay, perfect. If we choose -3, -3 minus 2, -3 minus 2, in this situation will be -1. And because we have -1, the second power, that will be +1. Okay, so in this case, will be positive. How about with the second one? In the second one, we have to choose one singular number between 2 and positive infinite. So we can use 3, we can use 4, you can use 5. It doesn't matter what kind of element we're going to take in the situation. At the end will be the same, right? So if we try to choose that situation, we can use the number 3. Okay, and 3 minus 2 is 1. In 1 and second power will be positive. Okay, according for this situation, the problem mentioned this value that's supposed to be greater than equal than -4. Greater than equal than -4. And gave us positive. So we can try to drop the number line and says, okay, both are supposed to be true and both are supposed to be false. But because we have one singular solution in the polynomial, we're going to have to provide a test point. Just like, for example, if you remember at the moment we're going to we apply like the graph in of the linear inequalities, the system inequalities, we provide a test point. And this situation will be useful to prove if both situations will true or one of them will be true or neither. I mean, we have in the first inequality, x squared minus 4x greater than equal than 4. Okay, let's going to prove is this right. If the answer is previously gave us a positive number. And remember, you choose, if I remember, number 1, right, Camila? You choose the number 1 like a test point. So, yeah, yes or no?
I said -3, like in the
-3. Okay, perfect. -3. Thanks. -3 second power minus 4, -3 greater than equal than eh, -4. Okay, so -4. Let's see what we got. -3 second power will be 9. 9 plus 12 greater than equal than -4. 21 greater than equal than -4. Is this true? Yes or no? ¿Es verdad? ¿Sí o no?
Sí.
Okay, for that reason, we can say, okay, perfect. It's true. On the other hand, we choose +3, right? X squared minus 4x greater than equal than -4. So we got 3 second power minus 3 times 4 greater than equal than -4. 3 second power is 9. 9 minus 12 greater than equal than -4. -3 is greater than equal than -4. Is this true? Yes or no? Mhm. Is this true,
Yes.
-3? Right. So for that reason, okay, because both terms, that will be that solution. Okay, in this situation, the number line located between them will be all this space. Okay, here and over here, because we have a one sequence solution. For that reason, at the moment we're going to apply the interval notation. If you wish, we can write like, for example, negative infinite, comma infinite. This is one way we can provide this answer, or another way of saying will be negative infinite, comma 2, union 2 with positive infinite. In both cases, the answer will be the same. Okay, let's go to provide another example. Okay, another example. And remember, if you have doubts or questions, don't hesitate to let me know. Okay, let's provide a body on hand. We have uh, 3x cubed. Interesting. 3x cubed minus 3x squared minus 6x greater than equal than 0. Okay, this is going to be the letter B. What is the first thing that we have to do? Remember, the first step that we have to accomplish in this situation is create the equation, the inequality into equation. I'm going to label like a number 1, just like a step number 1. We got 3x cubed minus 3x squared minus 6x greater than equal than 0. We can factorize this expression. Of course we can. We have the common factor between all these terms is 3x, right? And remember, the common factor is the number and the variable was present in the three terms, but it repeats in the less frequency. In the numbers, it's the greatest common factor. In the letters, we call common factor. And after that, the original equation must be divided by the common factor. 3x cubed divided by 3x, we have x squared. In the second one will be negative x, right? And another one will be -2, and that will be equal to 0. Now we must factorize. We can use the triangle technique. 3x minus and x positive equals 0. Give me two numbers, with their product gave us -2 and the subtraction gave us -1. Obviously will be 2 and 1, right? And we had three solution sets. The first one, 3x equals 0. For that reason, x will be equal 0. The second one, x minus 2 equals 0. So x equals 2. Third one, x plus 1 equals 0. So x equals -1. Okay, we have the three solutions. Now we have to rewrite the expression using the table of signs. Remember, in the first column, we must write the polynomial. All right. What will be the values of the polynomial? Oh, you can write for the first one, 3x. The second one, x minus 2. The third one, x plus 1. And the last one is the product between the three terms. That will be 3x cubed minus 3x squared minus 6x, okay? And this is going to be the first table. I mean the first column, okay? Mhm. We got the polynomial. Ta-da, ta-da. Okay. And the second one, we're supposed to have the intervals. Remember the smaller value of the three ones? Who will be the smaller value of the three solutions that we have in the equation? What is the smaller value? 0, 2, or -1? What is
Negative
this?
one.
-1, right? So we're going to start from, remember, negative infinite until -1. And because the inequality includes the equal sign, I'm going to close the bracket. This is going to be the first interval. All right, I'm going to close that one and create the second column. Now that will be -1 between 0 because that's the closest number between them. So will be -1, 0. Okay, that's good to know. So I'll apply the logical sense. Another one will be 0 until 2. Mhm. 0 until 2. Ta-da, ta-da, ta-da. And the last one will be, what will be the last one? Any idea? ¿Cuál será el último intervalo?
2 positive infinite.
Exactly, 2 positive infinite. 2 positive infinite. And we are creating the table of signs in this situation. Well, let's going to create the table of signs. All right, guys, remember, in the first one, give me one number between the interval located between negative infinite until 1. Until -1, sorry.
-5.
-5, okay. I'm going to label over here -5 because it's the chosen one, okay? 3 times -5 is -15. Okay, I don't care the number, but I do care the sign. That was negative. In the second one, -5 minus 2 is negative also. Excellent. For that reason, we're going to have a negative value. By the other hand, -5 plus 1, that will be negative, right? -4. So we had 3 negative signs. You know, negative times negative, that will be negative. This is going to be the first answer. Okay. How about in the second one? -1 until 0. We can use, if you wish, a -1/2, if you wish, right? Because it's interval between -1 and 0. So 3 times -1/2 is -3/2. Negative. Another one, -1/2 minus 2 is -5/2. Negative. All right. Another one, -1/2 plus 1 is +1/2. Positive. You know, negative times negative is positive times positive. Positive. Okay. So we have the solution set for the second one. Okay, the third one. Choose a number between 0 and 2. Could be the number 1, right? Could be a number 1. Want to give you an example. You know, 3 times 1 is 3. Result positive. 1 minus 2 is -1. Negative. 1 plus 1 is 2. Positive. Final result will be negative. And finally, 2 until positive infinite, we can take the number 3 if you wish. Okay, 3 times 3, 9, positive. 3 minus 2 is 1, positive. 3 plus 1 is 4, positive. For that reason, the final result will be positive. And we are creating this beauty, lovely table of signs. All right. Before to continue, did you understand how to create this table of signs? Yes or no?
Yes, Mr.
All right, then. Now it's time to provide the solution using the number line. Okay, for example, the problem says greater than equal than 0. What numbers are greater than equal than 0? The positive numbers. Oh, where's located the positive sign? Here and here, right? So I'm going to draw the circle in this column, one and another one, because in both cases include the equal sign. I'm going to stain the circles, all right? And I'm going to drop the arrow. One over here and another one over here, all right? This is going to be the nice and beautiful number line. And if you want to provide the interval notation, okay, the interval notation will be the union between -1, 0, union 2 with positive infinite. Okay. And if you,
Mister,
uh-huh,
why did you shape them?
excuse me.
Why do you put like the circles?
Because we stay in the circle because the problem includes the equal sign. And I put the circle between the column and the middle column between this one because we're looking for the positive solution because the inequality says greater than equal than 0. I mean that we have to use in the positive solutions. That's why. And I'm remarkable in what will be the intervals located in the positive sign. That's why. Okay. And finally,
Mister,
uh-huh.
one question. Why does it has to be like to the positive solutions? Is it always like that or?
No, because it's depending what the inequality says. Because the
Mm,
inequality says greater than equal than 0. What does that mean? That means the
mhm,
positive numbers, right?
mhm. Okay.
Okay. So we can say this one, x -1 less than equal than x less than equal to 0, or x greater and equal than 2. This is going to be the solution set. Okay. Questions? Bailito. Vamos a hacer otra. ¿Puedo borrarla, mover la cámara o todavía no? ¿Mm?
Un poquito sí estaría bien.
Ok, ya copiaron la primera.
Sí, sí.
Vamos. Abre ahí. Dun, dun, turu, tun. Es facilito, ¿verdad, muchachos? ¿O no? Facilito, facilito. Va, tenemos esto. The letter C, letter C. The letter C. 3n square. 3n squared minus 7n minus 6 less than equal than 0. Less than equal than 0. Less than equal than 0. What are you gonna do? What are you gonna do when we come for you, bad boys, bad boys? Well, remember, we have to create the inequality into equation. I mean, 3n squared minus 7n minus 6 equals 0. And we had to try to factorize this term. Remember, when we have a number different than 1 in n squared, we have to forget about it, the middle one, and trying to factorize. I mean, trying to looking for two numbers multiplied by the extremes. For example, two numbers multiplied by 3, 3 and 1. So 3n, n. Copy the first sign, negative, and another one is the product between their signs. Negative times negative will be positive. Now, what will be the next step? Well, another one, we had to try to look for two numbers that gave us, multiplying gave us 6. And the subtraction gave us 7. Could be 2 and 3, right? 2 and 3. Because 3 times 3 is gave us 9n. And minus 2n, we got positive 7n. And that's supposed to be negative. Well, in this case, this is going to be positive. This is going to be negative. Remember, to check the answer, we have to multiply extreme with extreme and the middle with the middle. And that's supposed to give us the negative 7n. Again, 9n negative and positive 2n. Negative 9 plus 2 will be negative 7n. That means, okay, perfect. We're performing well the factorization. If we did well the factorization, there's not going to be any inconvenience to solve for n. For that reason, all right, n equals 0. And we have two solutions. 3n plus 2 equals 0 and minus 3 equals 0. So n equals negative 2/3 and n equals 3. Okay. We have the solution set of this equation. Now let's going to create the inequality. Remember, polynomial, polynomial, the intervals. Remember, the smaller one, negative infinite, comma, negative 2/3, smaller one with the greatest one, I mean, negative 2/3, comma, 3, and the highest one will be 3 with positive infinite. And I totally forgot. Because include the equal sign, we must use brackets. Brackets. Only in the number, because positive infinite and negative infinite, we cannot do that because the infinite doesn't have an ending point. Okay. Now let's going to create the table. Yep. Da, 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 da. And remember, if you have doubts or questions, don't hesitate to let me know, all right? Falló el pulso aquí. Ahí se va. Aquí tenemos los, no muy bonito, pero por ahí se va. Okay. Now we're going to copy the polynomials. The first one will be 3n plus 2 and minus 3 and 3m squared minus 7n minus 6. Okay. Let's see what we got. All right. Choose a number between negative infinite until negative 2/3. Could be, if you wish, negative 2, right? Could be negative 2. So if we choose negative 2, you know, 3 times negative 2 is negative 6. Plus 2 is negative 4. For that reason, the answer will be negative. Another one, negative 2 minus 3 is negative and negative 5. You know, negative times negative, the result will be positive. Well, negative 2/3 until 3, if you wish, we can use 0. 3 times 0, 0 plus 2 is positive. 0 minus 3 is negative. Positive times negative will be negative. And finally, 3 until infinite, we can use 4. 3 times 4 is 12 plus 2 is 14. So positive. 4 minus 3, sorry, positive 1. So positive times positive will be positive. Okay, it's time to provide the solution in the number line. What the inequality says, guys. 3n squared minus 7n minus 6 less than equal than 0. What numbers are less and equal than 0?
Negative numbers.
The negative numbers, right? Oh, okay. For that reason, I'm going to draw the circle between the positive numbers. All right, stay in the circle because it includes the equal sign. And we got a number line. That will be the intersection between them. So for that reason, okay, because we have that situation, we can try to write the rest of the answer. I mean, the interval notation, this is the number line, the interval notation or the solution will be negative 2/3, comma 3. And because this is a conjunction inequality because we have intersection between these 2 points, we got x over negative 2/3 less than equal than x less than equal than 3. And that's it. That's all that we have to do in this problem. ¿Preguntas? ¿Está todo claro? ¿Está todo azul, muchachos? ¿O no?
Sí, mister, está todo bien. Todo bien.
Clarito, clarito. Bueno, entonces si Dios lo permite, ya el día de mañana vamos a comenzar con otro tema que en parte no es ni tan nuevo, ¿verdad? Porque eso ya lo manejan ustedes muy bien en una gran mayoría. Solo tendría que introducirle su aplicación. Es lo que le conocemos con el nombre de ceros de una función. Vamos a aprender a encontrar los del teorema, usar el teorema de Descartes para encontrar cuántos ceros tiene una función. Y eso se hace mediante la división sintética. Por eso les digo que la gran mayoría del proceso ustedes ya lo conocen, porque se aplica la división sintética. Solo tengo que explicarles unos lineamientos al principio, qué es lo que se hace, y el resto, pura división sintética. Bueno, entonces mis estimados aprendices, por el día de hoy hemos terminado con esta clase, ¿verdad? Entonces, si Dios los permite, los veo a la hora de physics, ¿ok?
Thank you, mister. Have a nice
My
day.
pleasure. Have a great and wonderful day. Take care of yourself. Bye,
Yes, sir.
bye. Díganme. Sí, bye, bye. No necesitan fotos, sí.
Mister,
Sí,
días.
buen día.
Que como ayer no fui a clases, mandé excusa y porque estaba de viaje y no mandé la tarea. No sé si se la puedo mandar hoy.
Mándela, no hay problema.
¿Está bien?
Dale,
Gracias.
chequen. Bye.